Hello and welcome to tutorial 7 of the platemaker wizard. So once again we go to add-ins, we go down to help, demonstration workbook, view instruction manual, we go down to table of contents and we select tutorial 7. So tutorial 7 is teaching us more about page 5 of the wizard. However, like the later tutorials, we also repeat some of the work we've done in the earlier tutorials just to really bed down the stuff we've been learning about the other pages of the wizard. So this exercise, we're also going to save the file and enter some more information on page 1 just to get used to using page 1 and the type of information we can enter. This is very similar to the previous tutorial and the ELISA assay we defined in that tutorial. So let's go ahead and do that. So we go back to the platemaker wizard, we close this window, we go create new data entry workbook, we're going to save the file. I suggest you don't save it to your register since you're practicing learning the wizard, though you don't want these builds inside your experimental register. I'm going to leave mine on though because obviously I'm teaching you how to use the wizard. So the project name, remember you save it under the tutorials subfolder. The project manager, type your own name here. So I'm Rod Benson. I'm going to type Rod Benson. Experiment title. So it's EGFR inhibitor experiment. Like so. And then the media used, I'm going to use RPMI. The well contents is MCF7 lysate. The experimenter name, I think you can enter your experimenter name here if you want to use the same name. I'm going to select Richard Feynman, who is one of my scientific heroes. Experiment duration, and it's C plate maps for details. It's an ELISA assay again, so it's going to be 3 plate replicates, and now we come to the other notes section. You can see in the other notes section we are going to record the dose of EGFR ligand that was used and just some other notes, so we'll do that. So it is the effect of 5 test compounds on an EGF time course on actually the phosphorylation of the EGFR receptor when MCF7 cells are treated with 100 nanograms per mil of EGF ligand. So we now move down to the experiment details, and you can see we want to enter the 4th of the 9th 2024. You can use the calendar button to do that as we did before, so we could do it this way. But the way I'm going to do it is I'm also going to show you can actually type the date directly in. So if I blank this, you can see that this date field is quite intelligent. So let me show you what I mean. So if I type 4, it works out that it can't be 40, so it puts the first bracket in. I then want 9, so I put 9 in, and then I put 20. I don't have to put the other bracket, 2024. You see it intelligently works out the date for you, so that makes it nice and simple. You don't really have to worry about typing the forward brackets. It kind of calculates the date for you. Okay, the cell confluency is 80%, so we type in 80%. So this is an example of where you might have particular notes for that particular experiment, and the notes I'm recording here is the fact that the inhibitors were all added 2 hours before the EGFR ligand was added to commence the EGFR time course experiment. Now you might vary certain things with it between experiments. Obviously that's not a good idea in terms of meeting the experiments together. They should ideally be identical, but let's face it, in the real world sometimes you might have slight alterations that you want to record between your different experiments. So let's record the pre-exposure information here. So we're going to say all EGFR inhibitors were added 2 hours before the addition of the EGFR ligand to commence the EGFR time course experiment. Okay, so that's that. Okay, so now we'll add that, and we've done all of our page 1, so let's move on. So on page 2, you can see we have 5 compounds, we're going to have 4 doses, and finally we're going to have 5 time points. So let's do that. So we're going to have compound, dose, and we're going to have EGFR exposure time. So the compound is a text variable. We're going to say CMP. Space, we want a start value of 1. Increment 1, we have 5 of those, so we generate the first 5 labels. Our dose is a log dose curve, and we're starting at 1, and it's logarithmic, and we want 1 nanomolar. We have only 4 time points, again it's increasing to 1000, so we add those, so there we are there. So we've got that entered. Then finally our EGFR time points we're going to have is 0, 1, 5, 10 and 30, and the dimension is minutes. So let's do that. So it's 0, 1, 5, 10 and 30, and now we have all our information in our section. So we've done this figure 120, should look like this. We're going to click next. Now we come to our dependent variables. We want 2 dependent variables, so it's our phospho EGFR, and this time it's going to be 5 and 100 microliters. So let's do that. So use dilution factor 5 and 100, and we're just going to add that. Oh, the dimension here is nanograms per mil, so we add this, and then we have our total EGFR. We're using the same dilution factor, so we enter here. We have no experiment controls, so we click next, and now we create this ratio we've done before. So this is the phospho EGFR ratio, and it's just ratio, and it's just phospho EGFR divided by total EGFR, and we click add to put that equation in, and then we click next, and now we're just going to build the workbook as is. So we click preview, and if you've done everything correctly you should end up with the plate maps shown on page 177. Okay, so if we now look at these plate maps, first of all we can see that we have triplicate samples and we have 5 time points. So it almost fits nicely into this plate, because you can see obviously 4 3s are 12, so the first four fit really nicely, but there's a little spillover here, which is why you can see this shift of 1 as we start each dose. You can see it jumping down in this diagonal. There's a nice pattern here, and this is kind of a really good demonstration of how the plate maps can help you understand what is happening. So for instance, if you only had 4 time points, it would fit really nicely, but because of 5 it's overhanging. Now at the moment, if you look at these maps, what you can see therefore is that the EGFR time course and the direction of layout of the repeat numbers are both in rows. Do you see that? So we have the repeat numbers going across in rows, and so does the EGFR exposure time. Now what we're going to do is we're going to change this so that the repeat numbers stay in rows, but the EGFR exposure time is now put in columns, because obviously we can't fit 5 across in rows, but we can fit it down in columns, because while we only have enough to fit 4 doses, if we put the repeat numbers in rows but we put the EGFR time in columns, then you can see we're going to have enough space to fit the EGFR exposure time, because then that will just take up the first 5 rows, because all the repeat numbers are spilling out across the columns. So you'll see this in a minute when I do it. So what we're going to do is, if we click reject, and we're going to change the number of columns from 12 to 3. So we're going to use a subplating area, and we're going to use leftover space just as before. Okay, and then we're going to click preview, And now you can see the direction of the repeat numbers are in rows, but the direction of the EGFR exposure time is now in columns. And the other important thing to realize is that up until now, we've always selected a subplating area that is greater than half a plate. But this time the subplating area was 3 columns, and 3 columns is divisible into 12. So because of that, it still fits nicely. So there is absolutely no leftover space in terms of columns. So what it's done, you can see, is it's now plating the EGFR dose down in columns and the repeat numbers in rows. So now you can see the 5 time points fit nicely in rows A to E. Now the second one doesn't fit quite well because the second one you only have 3 rows remaining, so this doesn't really work, as you can see. So they now spill out, so you still have this odd layout, but it's fitting much better in terms of here, in terms of this subplating area. So this is now showing how, just as an experimentalist, by using subplating areas, you can use a multidimensional layout where you're laying out the repeat numbers in one direction and the time course and the dose in another direction. Okay, so that's figure 121. So now what we're going to do is, realistically, if we now also change the subplating area of rows from 8 to 5, then it really will fit nicely, but it will end up with this space. So let's do that. So what we're going to do is we're going to change the number of rows to 5. So we reject this. We change the number of rows to 5, and this time we're going to uncheck the use leftover space. We click preview. And now you can see we end up with a very sensible layout where we have our 5 time points running in columns, we have our repeats running in rows, we also have our doses in columns, and finally we have our compounds, each compound on a separate plate, which is this figure here on the top of page 179. Now what we're going to do is we're going to see what happens if we instead use the leftover space option. So remember, we had no space here because 3 goes nicely into 12, but obviously 5 doesn't go into 8, which is why we have these leftover rows. So what happens now if we instead use the leftover space? So we'll click preview. And we now produce this fairly complicated looking map of figure 122. So you can see that the top part is still exactly the same, but now what's happening is the subplating area of the bottom part is now coming into play. So the way the algorithm works is, remember, the areas we've defined were 3 columns by 5 rows. So it first of all plates this bit, then that bit, then that bit, then that bit, which was fine. But then it's got the leftover space. So what's the leftover space? Well, it's still 3 columns, but now it's only 3 rows because there's only 3 rows left. So you now have these 4 bits below, which are 3 by 3 squares, and that's how this bit fills in. So it puts these first 3 time points, then there's next 2, so you can see those go out of sync, and this gives you quite an interesting dose distribution, quite a mess. Then you can see that the main part of compound 2 starts here. But obviously it does lead to quite a messy plate maps, which of course is not what you want. Now what you need to do to really understand this is please read figure 123, just to understand how the platemaker wizard is doing this. But there's the 8 areas, the 8 subplating areas that are being created when you select to use the leftover space. And in many ways, the subplating routine used by the platemaker wizard actually mimics the way the experimentalist might choose to lay out a plate, depending on the samples they have, so that the experiment can be conducted in the most practical way. The plate areas, of course, would work well if we were performing an experiment where we would chose not to investigate every time point for every compound. So what do I mean by that? Well, you can see that if you look at this compound here, this is compound 2. So compound 1 fits nicely across here. Compound 2 would fit nicely if it only had 3 rather than 5 time points. So if we knock out the 0 and the 30-minute time point, then it would fit in this little space here. And that would just fit nicely for compound 2. Now, you'll also note that the compound is tested at 4 doses, and we have exactly 4 little squares here. So if we knock out the 0 and the 30, then compound 2 will fit nicely completely into this plate, because you'll have 1, 5, 10 will fit in that space for 1, then you'll have 1, 5, 10 for 10 in that space, 1, 5, 10 for 100 in that space, and 1, 5, 10 for 1,000 in that space. So it'll all fit nicely. Then you'll get to compound 3. Now compound 3 has this full space here, so that's all right. Compound 3 will fit happily on that plate. And then compound 4, we would also need to eliminate 2 time points, so it would fit nicely into here. And then finally compound 5 will just occupy plate 3 on its own in the top half of the plate. So if you're not following that, don't worry, because you're about to see it actually happen. We're about to do that with the platemaker wizard. So what we're going to do is we're going to eliminate the 0 and the 30 for compound 2, and the 0 and the 30 for compound 4. And you'll see how all the plate maps then line up, and you'll get a nice plate layout of just 3 plates, but everything aligned. So let's do that. So what we're going to do, so this is described in here. So how we're going to do this is we're going to go reject. We're going to go back to the column names values page, and we want to this time pause the build at the build of the compound. So we're going to go pause build, we're going to go next, we're going to go preview, and we'll get the flat data table. Now what we want to do is we want to select compounds 2 and 4, because they're the ones we're going to remove the extra time points from. So compounds 2 and 4. We also want to select the 0 and the 30 minutes. They're the 2 time points we're going to eliminate. And then these points we want to remove from the flat data table. So we simply left click on row 23, we drag all the way down to row 82, then we right click and you'll see it says delete row, and we push delete row and they all disappear. And then we're not going to save the changes to the wizard menu, we're just going to push finish editing, which we'll do. And we let it build, and after it's built you will see we end up with this map that I described. So you can see this is exactly what we want, and you can see that what we have now, we have compound 1 fitting nicely in the top half of the plate as it did before. Compound 2 now fits in because it only has the middle 3 time points rather than all 5, so it fits nicely here. Compound 3 fits nicely with all its 5 time points, and compound 4 only has its 3 time points, so it fits nicely in this section, and compound 5 fits in the bottom as we described. So that gives you a good example of how you can use the plate maps and fiddle around with the flat data table to maybe eliminate some time points to actually get everything to fit nicely. Now, of course, you may not want to do that. I'm not saying this is how you do the experiment, but it shows the power of the platemaker wizard in terms of modifying things using subplating, using flat data table modifications to create the exact experiment that you want. Okay, so let's say though we don't want this experiment. Let's say we want to do something completely different. We want to actually have, like, we definitely want all our 5 time points. How are we going to do that? Okay, so what we're going to do now is we're going to reject this, because this is not the experiment we want, but it's just to demonstrate how we could have this experiment. So we're going to click reject, and this time, and this is really important, we're not going to use the go to button, we're going to use the previous button, and we're going to go all the way back to page 2, define columns page. So let's do that. So we go previous, 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 and then we want to untick the pause build button here, because we want all the information as it was. We don't want it to pause again. We're going back to the original plate builds that we had. So we do that. We're then going to click next, and now what we're going to do is we're going to go back to simply using the top half of plate for the compounds, but the empty 3 rows that we created when we don't use leftover space, we're going to add some controls to. So this gives you practice in adding some plate controls. So let's do that. So what we're going to do is we're going to use plate controls. We tick here, we're going to plate last, and we're going to plate on every plate. And we're going to inject the controls into our compound and dose and EGFR exposure time, so all three we're using. And you can see we're going to enter the DMSO 0 nanomolar control, but for all 5 exposure times. So let's do that. So we go DMSO, and it's 0, and it's nanomolar, and the first exposure time is 0, and it's minutes. And then finally, we're going to have 6 samples. You'll see why 6 works. So we're just going to make that 6 samples, and we click Add. The second one is DMSO again. And this time it's still 0, but this time it's the 1 minute. So we add to 1 minute. And then we have DMSO. And this one is going to be the 5 minutes. And then DMSO and 10 minutes. And then DMSO and 30 minutes. So if you've done everything correctly, you should have all those different ones entered. 0, there's the 5, 0, 1, 5, 10, and 30. So once all 5 values are entered, we are then going to go back to page 5. And this time, what we're going to do is we're going to put the controls into the separate area. So we want the controls in separate rows of the plate, because remember we have the set of rows below which are free. So this is in the leftover space. Interesting enough, we don't have to, this has no effect now. If we untick this, it'll look exactly the same because it's already reserving that separate area of the plate for the control. So we can either have that ticked or unticked. We'll leave it ticked for now, but I'll untick it. I'll show you it makes no difference. We also want the controls to be set by columns, so we put the layout, so remember it's a different layout direction. And now if we click preview, you can see it's gone to 5 plates. You can see that we end up with this lovely plate map here. So this is again the original experiment. So now we have our 5 compounds on 5 different plates with the 5 time points. So these are the time points running downwards here. Repeats are running across in rows. And you can see now that the controls are occupying this bottom part. These are the controls we defined. So remember we had 6 repeats for the controls. That's the 0, that's the 1. This is in columns. That's the 5, that's the 10, and that's the 30 minutes. So you can see how we've now designed a nice plate layout with the controls included. And just to show you, if I tick use leftover space, it makes no difference because the algorithm itself will always work out what space it needs to reserve for the controls. So therefore it reserves that space whether that's ticked or not, because that's how the experiment will work. Okay, so we've done that. So this is pretty much where we get to for this experiment. So what we can do now is we can just simply accept this build, and when we accept this build you will see it then saves it because we asked it to save it, and I'll show you at the very end it added to the experimental register. You should know where this is saved. If you want to see where it's saved it's Documents. If I go to the shortcut for platemaker wizard and I go Projects, Tutorials, Rod Benson, EGFR experiment, and that's the experiment that we've just saved there. You can see it just saved there. Okay, so that's entered. So what we're going to do now is we're going to move on to a slightly different part of the page 5 options, and this is the colored plate maps, text maps, and plate containers. So what we're going to do is we're going to simply go resume the last workbook build. We're going to click next, 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 next. But this time we're going to turn off the colored plate maps. So if we do that and we click preview, you will see that it actually builds quite a bit faster. And the reason it builds faster is because obviously not having to do the plate maps simplifies its build, because obviously the color plate maps take quite a time to build. Now we still have the text map, but once we enter this information, this is the only record of how the independent variables are actually plated on the plate. Now, this can still be useful. One reason you might exclude the plate maps is once you've actually got the design, you may decide, if you're doing the same template over and over again, to exclude the plate maps to make the build quicker, because you don't really need them anymore because you have the text maps. In fact, you can even go one step further if you want and remove the text maps and just have the basic container workbook, which means that once the data's entered, the only place that really records the association is here. Now, again, that's absolutely fine. There's no real advantage in eliminating the text maps because the text maps are a copy of this, so it almost saves you no workbook build time to do that, but you can if you want. So we'll click reject. Now, the final thing you can do, however, is you can also remove the plate containers, and that is if you have a plate reading instrument that can deliver the data as a single column of values. So there's not many plate reading instruments that can do that, but if your plate reading instrument can do that, then you might want to dispense completely with plate containers as well. So what I'm going to do is I'm going to now get rid of the plate containers, and I'm going to put back the colored maps, and we're going to build it one more time. But you'll see that now we have these options: flat data table plate by columns, or we can have flat data table plate by rows. Now, why do we need that extra option? Well, if you think about it, if we go down, it's explained here, but if you think about it, if your plate reading machine is delivering the data as a single column, physically you've got a 2D set of numbers because it's come from a 96 well plate or from a 384 well plate or whatever microtitre plate. So it's either going to have to order the numbers row by row to get to a single column, or by column by column. That's the only two ways it can sensibly do it. And so whatever way your plate reading machine does it, you have to match it to your plate reading machine. So you have the option to match it to either row by row or column by column. So what we'll do is, in our exercise, that we'll select it flat data table by rows, which is running this way. So let's do that. So flat data table by rows. We click preview, and when we click preview, and now you'll see we've built the workbook. It looks exactly the same plate maps, but you'll see a conspicuously missing set of container worksheets. In this situation, if we go to the flat data table, whereas here before you'd have all the different references to the container worksheets, again, for direct comparison, you can see here. Now, of course, they're just empty cells ready to receive the numerical data coming as a single column from your plate reading instrument. So we'll accept that. We shall now return to the tutorial. So we've worked through this. So one interesting thing to point out: if you decide not to select plate containers, then you either have to sort the flat data table, so it is either going down in rows, plate rows, or across in plate columns. And this can have an effect if you're using summary statistics on the control page. So let me show you what I mean by this. So if I do this again, so I'm going to resume the workbook, and this time what I'm going to do is I'm going to switch on calculate average on the control page, and I go back to this page. If I now preview again, it will build exactly the same, but this time we'll get a warning message as it comes to create the equations. And the warning message is shown on page 188 of the tutorial crib sheet. And what it's telling us is it's warning us that the calculate average maximum or minimum option may not be correct if the controls have been sorted. And so I'm going to say yes, add equations anyway. So we'll build it one more time. And the equations on this one will be completely correct. Also, please do look at figure 128, as this clearly explains how the flat data table is relating to the plate map in our particular build. So remember, we asked the relationship to be in rows, and that's exactly what it's done. So you can see as you move along in rows, you're moving down on the flat data table. So now we move to this section of the tutorial 4.7.3, where we talk about the colored plate maps, and really this is discussing how the colored plate maps can really help us designing our experiment, because you might design the experiment one way and then think, no, actually that's not quite right, and you just make changes live and move it to a different type of experiment using the preview key. So let me just give you an example of this. So this is the particular experiment where we have everything in triplicate, and you might look at this and think to yourself, well, this works, but actually I'm a bit short of cash and I don't really want to use up 5 ELISA plates per experiment, so I'm going to reduce this. So the first thing you might think of doing is saying, well, I'm going to reduce all the samples from triplicate to duplicate. So let's do that. So I'm going to go back to resume last workbook build. I'm going to change this number to 2, and then I'm going to go next. And the other thing I might think about doing is we're going to work actually towards this second layout, which I also have saved as a template. And in this second layout, you can see we're now in duplicate, and at the end here we have moved the controls from below in the rows to just 2 columns. So let's do that. So first of all, that means that each sample only has 4 rather than 6. So obviously the control area is a lot less, so we need to decrease the controls. So let's do that. So this is now going to go from 6 to 4. So we go 4, edit, 4, edit, 4, edit. So we're just reducing all these from 6 to 4, which we have now done. And also you'll notice that there can only be 4 little squares rather than 5, so we have to choose to delete one. So let's delete the 30 minutes. We can leave that alone. We now come to the final page, and on this page we're now going to move the controls into separate columns, and this time you can see that the repeat numbers are in rows and the exposure time is also moving across in rows. So in fact we're going to change this from 3 columns back to 12 minus 2 for the controls, so back to 10. This is now the full width of the plate, so we don't want 5, we want to go all the way back up to 8. And now we'll click preview. And when we click preview, what do we get? So you can see we have pretty much transformed the plate layout into something very similar to our instruction manual, but not quite. If you notice, there is some slight difference. So first of all, you can see the controls aren't in these squares. We can easily fix that. We've just got to change it from column layout in the controls to row layout in the controls. And also we have this same interesting problem here where the last set of controls is not on the edge here, but that's because there is this space at the end because we only have 5, not 6 compounds. So let's fix both those problems now. So the way we do this is we click reject, and we go, first of all, we're going to go back all the way to page 2, and we need to add 1 spacer key to get the controls on the last page to go into the right place. We go next. We also need to change this control layout direction to by rows, and then we click preview, and now you'll see it exactly matches this second layout. So you can see how we've moved from one plate design to a different plate design just by using the preview key, accepting, rejecting, making changes in the different sides of the menu until we get the actual experiment that we want. And this is also saved as a template, so you can see the template version of this as well. So the very final thing we're going to cover is new plate per experiment option. So what we're going to do is we're going to again go across to our program options, make sure it's in tutorial mode. We're then going to go create new data entry workbook. We want to select tutorial 7 new plate per experiment sample. And the first thing to note is that what we want to do is we want to have multiple experiments, but templates never save the multiple experiments. And the reason why is because obviously you would never want to save the multiple experiments with the template because they are set at the time you do the experiment, at the physical date you do the experiment and the notes that you make for that particular experiment. So templates will never have this section filled in. Now we want to have 3 experiments to demonstrate this functionality. So I could add the 3 experiments here, but in fact I'm not going to, because the problem is that I need to first load the template into the platemaker wizard before I add these, or otherwise it won't register these. So what I'm going to do is I'm going to click adjust template settings and click next, and then I'm going to go straight back, and now I can add my 3 experiments. So I'm going to add just 3 experiments. I'm just going to go with today's date and click once, and it always goes forward 7 days. So just put my 3 experiments in, which I've done now. I click next, 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 and preview. And when I click preview, you will see that what it's going to build for me is that it builds for me this 5-plate experiment, and you can see that the controls are only on the last plate. So this is a multiple experiment, but there is 3 experiments, and you can see that each experiment takes up 1.5 plates. So experiment 2 is split across the second half of plate 2 and all of plate 3 and then plate 4, and then as requested the controls are only on the last plate, plated last. Okay, so again, if we just reject that and go back and show you that on the control section, you can see they were plated last plate only. However, what we're going to do now is, instead of that, we're going to now click new plate per experiment, and you see it now jumps to 6 plates, and watch what happens. So now when we click preview, this time you can see that now the experiments are split as expected across different plates. When the first experiment comes to an end, the second experiment is now plated on new plate, which is what we requested. The third experiment is plated on a new plate as expected. But now the way the platemaker wizard deals with this is it puts the plate controls for experiment 1 on the last plate of experiment 1, the plate controls for experiment 2 on the last plate of experiment 2, and the plate controls for experiment 3 on the last plate of experiment 3. So this is an interesting example where now you have controls on every second plate, not on every plate, because obviously in controls you can select to have it on every plate. This time it's still plating last, it's still plating only 1 plate only, but it does it relative to the experiment number, not to the whole group, as it were, and that's explained in this final section, which is here. So read figure 130 and 131, and this gives you a good example of how you can end up with controls on some plates but not others if you're using a new plate per experiment and you're just using controls on the 1 plate of the experiment rather than of the whole group. Okay, so I hope that's clear, and that brings us to the end of this tutorial. And in fact, we're just about finished learning the platemaker wizard. I've now introduced all the necessary functions to you. The very last tutorial, we're going to look at a special case where we're plating from a 96-well plate to a 384-well plate, where we're using a robotic 96-channel pipetting head. In this situation, it strikes the 384 plate 4 times, so we have to use a subplating area of 2 by 2, and that is something which we'll look at in the final tutorial. But until then, if you like this tutorial and are watching it on YouTube, please do hit the like key, and please do subscribe to this channel so that more people will get to learn about the platemaker wizard. Until I see you in the next tutorial, I wish you well with all your experiments and have a great day. Bye.